This video demonstrates the Thevenin's theorem for the AC circuits. In this case, find the Thevenin and Norton equivalent circuit between terminals AB, means these two terminals. Yeah, so we'll see this circuit. There is a one voltage source here, 50 volts, only single AC source with phase angle is 0 degree, 5 ohm and inductor of J5, 2 ohm and inductor of J3, and 6 ohms. We have to replace this circuit with Thevenin and Norton equivalent. To replace what that statement of Thevenin, any source, any network can be replaced by a single source with a single impedance. Between these two terminals, means first step is to determine the voltage between these two steps. Second step is replace this entire circuit with a single impedance. While converting that, if any source voltage sources are there, those should be short circuited and current sources should be removed. So while calculating the Thevenin impedance, so we'll go for the first step, Thevenin voltage. So this is a circuit. I'm going to call it as this A point, and this is a VAB, voltage across AB. I'm going to use node because there is only one single node here in this case. Otherwise, there are two mesh equations. Means I have to solve these two mesh equations. Even if final answer is same. So hence, okay, I'm going for a node analysis. This I'm going to call it as A. It is a VA. With respect to this, it is a voltage A. VA. So I will determine the VA, then I will determine the VAB. So node equation is VA minus 50 divided by this 5 ohm, VA by J5, VA divided by 2 plus 6, 8 plus J3. So this is, so convert into polar form so that the simplification. VA minus 50, VA by 5, it is a 0.2 and minus 50 by 5, so that's I taken it to the right side. And then polar form, then simplified rectangular form, then VA is equal to 10 divided by this, convert into rectangular to polar form, that is a 10 divided by 0.39, 0.2786. Yeah, so this will be it is a minus here when I take and dividing here, 10 by 0.39 is a 25.6. Its phase angle is 0. When it comes to the numerator, it is the plus. This is the voltage at this point. But I have to determine the voltage between these 2 points. That is the voltage across 6 ohms. I hope that okay, these polar rectangular conversions are already you may be knowing with this. I'm not going in detail how this conversion done. Yeah, now I will find out the current through this branch. That is I'm going to call it as IAB. There is a VA 6 plus 2, 8 plus 3. So simplification. Then 3 with 17.31. This is the current. Next is the drop across this is into 6. That is 18.31. 18 volts with phase angle of 17.31. That is a VAB. So next step is impedance. So impedance short circuit this. When I shorted here, these 5 and J5 are parallel and that will be in series. Again, that is in a parallel. So that is a one thing. So first 5 into J5, that is 5. Plus, because that will come into series, 2 plus J3. That again, this entire will be in parallel with the 6 ohms. You did it a simplification. This is the one. And again, 2 plus J3. Then 6 ohms. These two are in parallel. Simplification, I'm going to get a 3.6 with the 23 phase angle. Or you can convert into rectangular form. So this is the voltage and this will be the impedance. Yeah, this is the Norton sequence. Simple. Divide 8 by 3.31. It is almost nearly 5 ampere.